Today we'll be investigating radian measure. So to get started, a degree is the angle subtended at the center by any arc. A radian is much like a degree, where it is an angle subtended by an arc at the center of a circle. The ratio of the arc length to the radius defines the angle in radians. So a formula to find the angle in radians is length of an arc over radius. Now we will look at the relationship between radians and degrees. Radians are used in trigonometric problems to substitute degrees. Angle ABC, which is 1 radian, over 360 degrees, that equals to the arc length AC, which is the radius, over the circumference of the circle, 2 pi r. Now we can cancel out 360 degrees by timesing both sides by 360 degrees, and now we can cancel out the radius and divide 360 degrees by 2. Now we get 1 radian equals 180 degrees over pi. Now we can times both sides by pi to get pi radians equals 180 degrees, which therefore means 2 pi radians equals to 360 degrees. Following on where we found that 1 radian is equal to pi over 180 degrees, we now have the formula to change from radians to degrees. Radians equal pi over 180 times by the degrees. Degrees equals 180 over pi times by the radians. An area of a sector equals to half radius squared times radians. This is an easy table that helps us remember the radian measure when used in trigonometry and are related to the triangles. These two triangles give exact trigonometric ratios and can be drawn using radians instead of degrees as shown. Make sure your calculator is in the correct mode for this next section. Radian for when working in radians and degrees for when working in degrees. So when we put sine pi over 6 in our calculator, we get 1 over 2. When putting in sine 30, we should get 1 over 2 as well. It's the same thing with cos pi over 4 and cos 45. When putting the equations into the calculator, we get root 2 over 2 both times. Now it's time for some examples. A. 60 degrees times pi on 180 equals. So with this, we can now divide 60 degrees with 180 to get pi over 3. B. Sine 5 pi over 20 equals. First we can simplify the fraction 5 pi over 20 to become sine pi over 4, which then equals to root 2 over 2 from the exact triangles. C. Evaluate sine pi over 6 cos pi over 4. Using the exact triangles from earlier, we can change sine pi over 6 to 1 over 2 and cos pi over 4 to root 2 over 2, which equals to root 2 over 4. The diagram shows that the circle centered O has a radius of 5 and arc AB is 7. So we're trying to find the area of the shaded sector OAB. So if we put the given values into our formula, we will get area equals 5 times 7 all over 2, which then equals to 35 over 2, and we leave the fraction as the question is asking for an exact value, so the answer is therefore A. For this question, we can see that the triangle OAB is a sector of a circle with radius 6 centimeters and an angle of 30 degrees. So for the first part of the question, we are trying to find the exact value of the area of the triangle. So we know that the formula for the area of a triangle is area equals half AB sine C. From what we have learnt so far, we know that 30 degrees converts to pi on 6. So adding the information into our formula, we get area half times 6 times sine pi over 6. We can then simplify the sine pi over 6 to 1 over 2. So our formula now is half times 6 times 6 times 1 over 2. Therefore, the area for the triangle OAB is 9 centimeters squared. For part 2, we are to find the exact value of the area of the shaded segment. In the previous question, we found the area of the triangle, which can be minused from the area of the sector to get the area of the shaded segment. The formula for the area of a sector is area equals half radius squared radians. So the area of the shaded segment equals to half times 6 squared, because the radius is 6 centimeters, times pi over 6 and minus 9, as this is the area of the triangle. Therefore, the shaded area equals pi over 12 times 36 minus 9. Now we're going to simplify the fraction further by dividing by 12. Therefore, the shaded area equals 3 pi minus 9 centimeters squared.